correcting initially for the drift versus correcting in real time for the drift. But it doesn't mean, because it's a known direction of drift, right? It's a known amount of drift. It's not like the Coriolis force is random. It's a known effect. I take it into account as soon as I leave the ground.
Your lines don't change no matter what you try to say is going on. A curved line from point A to point B is never going to be the same as a straight line.
What makes you think it's a curved line? I know when I take off, Jeremy is just, putting his
okay. Let's hold on. Let's do this as a thought example. Get out a sheet of paper, put a point on one side and a point on the other side, mark 1A and mark 1B.
Mm-hmm.
Now put a pencil on point A and make 0 corrections to point B. What do you get?
Straight line.
Awesome. Now take that straight line, go back to point A. Now make any deviation from the path that you just drew.
Napalm, I know what you're imagining, but there's a part of this you're missing, which is the simple part. When I draw that straight line from point A to point B, that's the example that he had first. We're both going from point A to point B, but in this case, the point B moves as we move. Point B doesn't just sit there like it does on your piece of paper, right?
Yep.
It moves. And during that time,
here's where you're getting it.
Wait. Let me finish. I am correcting in real time for the exact amount of motion that point B is doing. Okay? So
cool.
As you draw your first inch towards where it will be in the future, I draw my first my inch, and I'm drawing it directly towards where point B will be. It's the same thing.
It's not the same thing, though.
So if you take away the paper, because what you're doing is you're thinking in terms of the ground beneath you, not the paths that are taken. So
I'm not thinking in terms of the ground.
If we're making the correction, dude, here's the thing. Point B is always going to end where the scenario ends, right?
Mm-hmm.
It's moving.
It's B1 to B2, or B0 to B1, call it.
Right. So no matter what happens in that scenario, if I start in a direction that is not exactly to where point B is going to end up at the end, if I am not pointing exactly at that spot prior to point B initially moving, I'm going to take a longer path.
So you're talking about like the width of the plane, like longer, like one.
Even if it's the width of a plane, it's a longer freaking path.
Okay, all right. So by a infinitesimal amount, because it's like if one plane.
Holy crap! So let me ask you a question.
Napalm.
That's like omnivore. Look at the diagram that I just put in the chat. It explains it very easily. If you're going from point A, which is the blue dot, and you're taking that green line straight down to point B, and the Earth didn't move and it was completely stationary, you could do that. But if your point B is on the equator at 1,000 miles an hour, that city that you're going to land in is moving faster than you are when you start out. You may have only 100, 200, whatever miles per hour and conserve momentum. But since point B is at 1,000 miles an hour, so that city is moving faster than you are, which means it's going to be deviating to your left certain amount where you're going to have to then chase the target, and your path is going to be longer. You might as well just start out like that third line that goes straight across to where point B is going to be and get there. But even if you did that, you still wouldn't be able to land the plane because you'd have to continue accelerating as you're slowing down to land, and you could never land the plane if you're going to a place that's faster than where you started off from.
So I think that's a great.
I
think that's a great argument. Planes can never land. I like that. That's airtight.
Well, it's common sense.
Right. Okay.
Yeah, because you'd have to continue accelerating. Well, tell me this. Is it a fact that the plane would have to be in perfect sync eastward tangentially with the Earth as it's landing because it's treating the Earth as stationary?
So
doesn't the plane have to move in perfect sync eastward with the Earth?
The plane is getting lift from the atmosphere, which is moving in sync with the ground.
So
right. So it's carried by the Earth spin. It doesn't have to
carried by
accelerate to 1,000 miles an hour to
have to accelerate the extra amount. So you're saying the wind blows in one direction to push the plane sideways? Is that your theory?
No, I'm saying that the atmosphere, which is responsible for generating lift, is also moving. There's a conservation of momentum that happens as you fly over a globe, but that's not even the situation.
That's not conservation of momentum. The atmosphere pushing the plane sideways, first of all, that would be a wind, by the way. Secondly, you don't get the conservation of momentum from the atmosphere. The conservation of momentum is from the plane being on the Earth when it started off.
That's true, but as it moves in the atmosphere, momentum is imparted to the plane as in the form of.
But you got winds going in all directions. What are you talking about? The plane could be pushed eastward, westward, north, south. It could be pushed in any direction by the wind.
Okay, new perspective. I think you should just stick with planes can never land. I think that's probably going to be your best bet.
We're getting there because you don't have anything to stick with in your own argument. You don't have anything to stick with. You're just saying, oh, the atmosphere. What is that? Is that a wind?
No, it's the massive air
so how does it push the plane?
It doesn't push the plane.
Well, it have to for the plane to accelerate the extra 500, whatever amount it needs to be in sync with the Earth.
Okay.
Can you at least agree that the plane would have to be in perfect sync eastward tangentially with the city it's landing in so that it can treat the runway as stationary? Can you at least agree that would have to be the case?
Yeah, I think so.
Yeah, so how's it going to gain the extra momentum when it can't even gain momentum? It can accelerate the extra amount, but it can't stop accelerating with that extra amount as it's slowing down to land.
Okay. Like I said, so this is a completely different situation than.
No, it's not.
Yes, it is. So
it's what you're talking about exactly, but it's
no.
And act like a straight line is curved and it doesn't even matter, and it wouldn't even go a longer path, and it can just fly straight there, and the atmosphere helps it. Just make it all up in your head. It's a make-believe story that you think it all works out, but it technically wouldn't. And we're talking about people's lives in the hands of the pilot. It would be one answer that everyone would have. It wouldn't be a variation or a guess or an estimate.
Calm down, new perspective. Okay. If you want to, you can talk to High Flyer about it or one of the other pilots. But
you don't know. That's why, right?
I'm not. It's not an especially interesting argument. What I'm telling you.
It's very interesting because it's a thing that happens every day that couldn't happen unless it happens exactly the way they say.
No.
There is no answer for this. There is no answer for this, by the way. Okay. I've checked with pilots. I've checked with everybody. There is no answer.
Okay, I'm sure you have.
This debunks your globe, by the way. This is the end of the globe.
I'm sure it does. Yes.
Okay, great. Then we're on the same page.
Mm-hmm. Okay. So what I was talking about with napalm is that if you're going to say that the difference in path distance is solely equal to the starting attitude of the airplane, then I'm going to agree, even though it's only going to be like 2 or 3 degrees of difference. So
what are you talking about? Why are you going back to estimates and trying to minimize it? The plane would have to be in perfect sync with the city that it's landing in. How's it going to do that? If you don't have an answer to that, what are you talking about degrees for? What are you talking about little estimations and trying to minimize it for anybody here? We all know that it wouldn't be in perfect sync. And even if it were able to do that, the pilot's not trained to do that. He would need to be. And even if he was trained to do that, he wouldn't be able to stop accelerating in that direction sideways as he's landing on a north-facing runway going south. So there is no answer that means we're not spinning. The only way a pilot can treat the Earth as stationary as if it's actually stationary. It's as simple as that.
Right. I'm sure you believe that. But that's
no,
not
it's nothing to do with belief.
particularly.
It's a basic fact. I just said, how can you believe otherwise? How can you think it would work otherwise? How does the pilot treat the Earth as stationary if it's actually moving?
Because the pilot is moving with the atmosphere. The atmosphere around.
What?
The same reason why. Yes.
So the atmosphere is a wind pushing it sideways.
Okay, so you're gonna not let me talk. I got that. I get that new perspective.
Now you're looking for an out.
No, I'm.
Go ahead.
You could let me talk. Okay. So the reason why a helicopter the Earth doesn't rotate under a helicopter. It's the same. I believe it's the same thing that's happening. The helicopter is getting lift from the atmosphere, which is moving at the same speed as the Earth below it. So it's not that a wind blows it along with the with the atmosphere. That's not what happens. It's not like when I take up a wind suddenly comes and blows me along to keep me in the same location. That's just the entire medium is all moving with the same momentum, the same rotation as the Earth. So
but the reason that we allow you to beg the question with the helicopter, if it takes off from the Earth, right? It takes off from the Earth, and we say, okay, it was on the Earth, so it has that conserved momentum. Fair enough, even if we give you that. If the helicopter flies to a city that's going faster than where it started off, it doesn't gain momentum from the atmosphere, and if it does, then we're talking about a wind. You can't answer this.
Okay, so anyway, as the plane continues its path, and in this case, I guess we're heading towards the equator, flying straight around.
500 miles per hour faster at the equator.
Latitude. Okay.
How's it gain the 500 miles per hour eastward tangential velocity?
Because
so it can treat the Earth as perfectly stationary.
Because the atmosphere that is providing is moving at the same speed as the Earth at each latitude. So
the wind, atmosphere. What's the difference between the wind and the atmosphere moving?
So wind is pressure, an air pressure difference that is not related to the, it's different from the regular atmospheric pressure. So it's a normalization between two different pressures.
Okay, great. So then how's the atmosphere push the plane if it's not a wind?
Because, do you know what lift is?
Sure.
You know what lift is when it comes to like a plane or a helicopter?
Sure, I do.
Okay, so the plane is getting lift not from a wind, right? It's getting lift from the atmosphere itself.
Yeah.
Okay, and that wind has a certain, velocity that it is the same as the Earth, right?
The wind has a velocity. Now you're calling it a wind.
No, the atmosphere. The air.
The atmosphere has a velocity that's not a wind?
Yeah. The wind is is equalization
of the plane.
All right, listen. Are you going to let me? Okay, so the way it pushes the plane is the fluid medium of the atmosphere plane and gives it lift. So as the plane continues to head, in this case, south towards the equator, it is going to be, as it gets lift from the atmosphere around it, is going, moving in concert. I guess you could say accelerated with the Earth itself. So they're both going to be, by the time it gets there, because it's using the atmosphere, it's going to have the same, it's going to be able to treat the runway like it's stationary.
Okay, now, can we just break down the problems with all of what you just said? Can you just hear me out? First of all, the atmosphere acting like a wind would be a wind. Okay, it's pushing the plane. It has to act on the plane like a wind. It can't just move the plane. You can have this kinematic concept, this rule that you just write into this kinematic concept of it always being in concert with the Earth, no matter which winds are blowing and no matter which way the Earth is turning, it's automatically going to be in this eastward tangential lockstep. First of all, your side doesn't even try to argue lockstep anymore with the atmosphere because we have fluid dynamics. So it already is going to be off, even with the theory working perfectly, like you say, even though it doesn't work. even if it did work, it wouldn't be in perfect lockstep, so it could treat the runway as stationary.
Are you a expert in fluid mechanics?
I'm a pilot, or if I'm an expert, because you want to appeal to authority now that you're.
No, I'm just wondering.
Common sense, brother. Common sense.
Okay. So
common sense. How
I'm
is
just
the plane
wondering.
without being a wind to begin with? Now
I'm
wait.
just
Hey guys, you
confused.
gotta go one at a time. It's unbearable. It's
No, I'm
seriously
not done yet.
unbearable.
I'm not done yet. Let me just say this. Even if it worked perfectly like you're saying, it would have to accelerate the plane that extra amount that it was missing from being on the Earth where it started off, right? Even if the wind or atmosphere, or however you want to think about it, were to accelerate the plane extra amount, right? It's not adding momentum to the plane. Even so, even if it was accelerating the plane the extra amount, it would have to continue accelerating the plane in that direction as it's slowing down to land. And it wouldn't be able to do that. So you can think about it kinematically. You can just write the rule in and it's automatically in sync. But you can't just dynamically allow that to be the case in your actual working out of how it would actually work in reality.